Hi, my name is Jason Mimic, and I'm a technical director here at MongoDB working on the partners team. In this section of the training, we'll be learning about the new Kubernetes support available in version 4.0 of MongoDB Ops Manager. Note that this feature is being released in a beta format for version 4.0, and we do expect a GA release sometime in the latter half of 2018. In this section of the training, we'll cover some of the basics of what Kubernetes is, the new features available in MongoDB Ops Manager which integrate with Kubernetes, and also have a chance to see firsthand how everything works with some hands-on exercises. You might have seen the title of this section and asked yourself, why is MongoDB a database company even doing anything with Kubernetes? Isn't that some cloud platform thing from Google? And this is actually a valid question. Why are we spending resources on building an integration with Kubernetes? To understand this, first consider our target customers. These are primarily large enterprises that need to support many applications, all of which need databases. We want them to be able to very easily run MongoDB in whichever way they want or need to. We want to eliminate any roadblocks and make their lives easier. Recently, with the incredible rise in cloud and cloud-ready or cloud-enabled technologies, platforms and frameworks to deploy and manage applications and infrastructure have emerged. There are a number of these types of systems, typically labeled Platforms as a Service, PaaS, IaaS, Infrastructure as a Service, and various other acronyms. In this space, Kubernetes has emerged as the leader and is supported now by all the major cloud providers and commercial vendors such as Pivotal and Red Hat. So, in order to drive adoption of our enterprise products like MongoDB Ops Manager and Enterprise MongoDB, we decided to build an integration to make it easy to run MongoDB on Kubernetes. Kubernetes is an open source platform for managing containerized workloads and services. The containerized part of this definition is important. Kubernetes, sometimes abbreviated with the small k, the letter 8, and s, is a control and monitoring framework for containers. Containers are an operating system level virtualization method for running multiple isolated Linux systems, each a container, on a host using a single Linux kernel. You can think of a container as a very lightweight virtual machine. The master node in a Kubernetes cluster contains services to support the REST API, scheduler, and controller manager. It uses a special database called etcd to store various configuration and other data. Each cluster contains one or more worker nodes. These nodes contain components which communicate with the master node and also manage the containers running on the node. The fundamental concept of Kubernetes is a pod. A pod is a logical unit which encapsulates multiple containers. One could imagine running an entire application stack within a pod, but this is not usually the case. Each pod runs on a particular Kubernetes worker node for isolation. In fact, as you'll learn, a MongoDB replica set running with our new Kubernetes operator manifests itself as a pod for each MongoD instance. Docker is usually used to manage container images. See the reference notes to learn more about Docker. Our deployment of MongoDB through the operator will use stateful sets. These are higher-level Kubernetes objects which can contain one or more pods, can use persistent storage, and which are guaranteed to preserve network identity across restarts.